Hello and welcome back to a new video here on the Ludwig Fusel channel. Now, in today's video, we're gonna step again away from actual coding and go back to managing your projects. Now, previously what we have done is we have completely just relied on Visual Studio for managing our builds and our setup and our workspace and have everything like administrated from within Visual Studio. We have done all the project administration in Visual Studio, we have done the coding in Visual Studio, and we have done the debugging in Visual Studio. Now, debugging and coding, it's completely fine, right? Visual Studio has amazing tools. If you are installing something like Visual Assist, you can even increase your versatility of Visual Studio and have an even better experience using Visual Studio coding in Visual Studio. Visual Studio has by far the best debugger available to debug your applications, everything, if anything goes wrong, to find issues and to actually fix them. So yeah, there's no problem with that. However, when it comes to project management, and I don't mean like project management in terms like of Jira or doing tasks. I mean like technical project management, managing your code project, not your like your management project. But the idea is like project management in Visual Studio is a bit hard and a bit repetitive. It's not exactly how you want to have this on a bigger project. And the biggest problem with Visual Studio, it's Windows only, right? I mean, in theory, you could actually build for Linux from Visual Studio, and there are ways to kind of like do this, maybe even with cross-compiling with GCC and custom toolchains. Probably there are features and possibilities to do this on Windows and cross-compile for Linux and use this with Visual Studio. But in general, the idea is if you have a Visual Studio solution, it is Windows only. So if you want to also automate tasks like building this automatically on a server with pipelines, running unit tests, running benchmarks automatically on a server, Visual Studio is gonna fall apart because you have a solution and then your like Git runner, your GitLab or GitHub runner needs to be a Windows machine to be able to do this. It needs to have the full Visual Studio toolchain with MS build, Microsoft compiler and all the libraries to run that. I mean, if you have Windows builds, it's always required. However, what you want to do, especially in development and DevOps, you want to always have like a path to kind of like build and test your application on Linux, and you also want to, in general, also have options to compile and run your applications on Linux and not just Windows, especially if you're doing like server-sided software. If you're doing like some game engine stuff, it's completely different. It's not that of a big of a deal that it's not cross-platform. I mean, yeah, kind of like if you have like Xbox or PlayStation or Steam Deck, you want to, of course, have different build chains, but most of them integrate within Visual Studio. So Xbox has a GTK available on Microsoft that integrates Visual Studios. For the gaming side, it's not that big of a deal. In fact, if you are using a build system, it might even make your work harder to integrate these platforms. Of course, there are build systems that are extensible, like the one that we're going to use today, that allow you to basically write your own extensions so that you can fix these problems, especially if you're doing this like as a business. If you're not doing this as a home user or just learning purpose, then you're going to have the resources to also use these systems in the right way so that it works with your target platform. And for the home users, most of the case, Windows and Linux is enough. And for these two platforms, the build systems or any build system that's out there is definitely way built and tested for that. So the main problem is what we wanted to solve today is we want to solve that on the right here. We have the solution explorer that we use to create like folders for the exercises. That was a concept that I've dropped because nobody watched my solutions video, which was a bit sad, but yeah. And yeah, when we have added like all of these projects, we always went here and said add new project. And if we added a new project, we need to make sure that the path is correct, that we select the right template as soon as the project was created. I'm not going to do this yet. Here, we have to go to the properties. We're required to copy over the output directory, the intermediate directory, set up the target name, set up all the visual, the language features like CPP20, the directories when we went for like using ini-pp, which I think we haven't done in here because it's not a library, right? Yeah, it's not a library, but get like the point. We have done all of the setup manually, but what you want to do on a proper project is you want to have this all automated. You want to have like a way to say, all right, I want to create a new project of an application, and then the project of the application is automatically created, and all the settings are shared between all the projects in the same way. The output directories are built in a uniform way. You have proper ways of setting up your debug builds. For example, I think on the ini Explorer we used debugging arguments, command line arguments. You want to have a uniform way of defining them, and also a uniform way to also use them on Linux, right? Because every setting that you do here, it's just Windows only. If you then write a separate tool chain for Windows with like make files, for example, for Linux, I mean, with make files, for example, then you have to do all that setup again to allow you to build this the same way on Linux, and then you have to maintain 2 build systems, and if you add another platform you have 3 build systems, and it's gonna quickly grow, and yeah, it's not gonna be ideal. So that's what we want to solve today, and solving that can be done in multiple ways. There are build systems that are meant as a tool that runs solely alone. So a build system in general, the idea is you give it a collection of source code and a collection of setting values, and it produces your binary. For example, CMake is a very common build system, and CMake in general, at least on Linux, it's mean that you say CMake build and it generates everything automatically and spills out binaries. However, on Visual Studio, we like to actually work in our solutions and project setup. So what I want to do is I don't want to alter my normal workflow that I do while coding. I don't want to alter anything. I want to have my projects. I want to have the files in the projects. If I add a new file, it should automatically be in the right location. I should have a complete solution that can be executed, and everything should still be like in the Visual Studio way, just that the projects and solutions is not generated by Visual Studio, but it's generated by a build system that is going to provide you a way to do this, and also do this cross-platform. And the build system should ideally on Windows generate myself a solution, a Visual Studio solution, a .sln file, and the project files. And on Linux, it should generate make files that I can build by calling the make command on Linux. And if I do that correctly, the idea is in general that you have like one file inside of your project that you're gonna run, and then the project is being created, and then in Linux you can do make, and in Visual Studio you can open up the solution and you can start coding. And that's what we want to do today, or maybe even the next few videos, because build systems are not that easy to understand, especially if they are complicated, and there are so many options that we can talk about, so that we're going to see how far we're going to get today. Alright, so the first thing that I want to do is I want to close Visual Studio to get started with that, and I want to open up Visual Studio Code, or maybe let me open up the project first. So CPP tutorial, let's right click this and say open file location to go where it is. Let's go one directory up, show more options, open with code, so that we have a Visual Studio Code instance here, and let's maximize that, maybe make it a bit smaller because this is a bit large. I think that should be even fine for you. And I didn't push the latest changes, but I think I have made that video, right? I have done that video. Come on, have I done that? ini-parsing 2 from 2, but I haven't published the code. That's good to know. So ini-pp, no, yeah, let's just call this ini-pp 2 out of 2 quickly. Let's commit these. So, okay, that's something that I need to later on make sure that I set this up in GitHub. I wasn't aware that I haven't provided you the code yet. Why did nobody notice? I don't know. Alright, so currently you can see that my CPP tutorial is built like that. You can see that we have all of these directories which were created from within Visual Studio. We have the root SLN file, and we have the VCX project files. What I want to do now is I want to migrate this so that it runs also on Linux, and that you in general have like all the options to make this like a bit more versatile. Okay, we need to do a complete cleanup of that project first, because all of these solutions files are already there. So what I want to quickly do is I want to delete all Visual Studio related files. This is now just required once because it's already integrated. So let's delete all of these Visual Studio files. All of them. We don't need them. I could try and automate this. or also select multiple ones. Maybe we want to select multiple ones. Yeah, no, it's going to be harder if we select multiple ones. I don't know how Visual Studio Code handles all of this, but we're just gonna delete them all from here. It's a bit hard to do this by hand, but it's not that big of a deal. So there we go. All of them deleted. No, I don't think that I've got all of them, because we also have like the exercises here. Yeah, exercises also have the solution in here. Now we are there. All files deleted that are Visual Studio related. That's good. Let's keep this here as is. We're gonna modify this later so that you see that it works. And now all of them are deleted. I might already wanna stage all these changes so that Git is a bit more up to date. So now they are staged. I think I should no longer be seen as changes, and later on Git can handle this a bit better. All right, so now that we have deleted all of these Visual Studio related files, we need a way to get them back. And we get them back by using a build system. And I want to use a build system called premake. So what I'm going to search for is I'm going to search for premake, and the first result is already the right one, premake.github.io, and this is a powerful, simple build configurations. So it's not really a build system, it's just a system for writing build configurations. So you write the configuration, how your project should look and be configured, and then you're basically going to generate the files for Visual Studio or Makefile to then build it in a separate step. However, most of the time you call it build system because it is kind of like a build system, because we're going to later on also write scripts. And these scripts are going to completely automate stuff, especially on Linux, so that you just run one script and everything is done. And then it's kind of like getting to a full build system. All right, so what we want to do is we want to download premake. I'm going to click on download premake, which is going to give me pre-built binaries, which is what we want to look for. And now you can select which platform you are on. I'm currently on Windows, so I actually want to download that one. It's going to download your zip file, and if I open this up, we have a hell of a lot of files in here, but we just care about premake5.exe, so we can copy premake5.exe, go back to my documents, CPP tutorial. Now we just need a way where we're going to put them. I'm going to create a new folder called bin for binaries, and instead of this bin folder, I'm going to paste in premake5.exe, and I'm also going to rename this to premake5-windows.exe, because we also going to later on have the Linux version in maybe a next video where I can show you how you can build this on Linux. And yeah, so it's good to have it separated. All right, so there we have it. There's the exe file, and you could try to double click it, but we're going to run this anyway, but it's not going to do anything because actually this is a command line util, right? Premake5 is a command line util, which means it's not a GUI based application. It is based on a command line. I can see here in Visual Studio Code we also have the exe here. So to actually execute this, I actually want to create a new file, and I want to call this one, I'm calling this devtool. devtool.py. This is now a Python script, and I know we are on a C++ series, and that's the first time that we are doing Python here, but Python is the ideal programming language to automate your repository, your Git repository, your code base. It's very easy to automate this with Python. So devtool.py, it's the Python file that's going to be used for automation, and Python file devtool is going to be responsible for, basically calling premake. I'm calling this devtool and not like premake.py or something like that, because it might do more in the future. And to actually call premake, we need a few imports. We want to actually import maybe OS, maybe sys, and maybe how is it called? I've forgot the sub process. I think it's called sub process. Yeah. And then we have a few modules. We might not need them all just yet, but these are the most commonly used here in Python, so we're going to use them, and we're probably going to use them. We're gonna do this odd Python main thing. I don't know. I kind of like find this a bit odd how main is done in Python, but yeah, it's okay. This is how Python rolls with main files. It's okay. And what I want to do is, for now, I just want to call premake. So how do I call premake? Well, calling premake is actually quite simple. We want to call it a new sub-process. What I'm going to do is subprocess.run, and then I'm going to give it a command, and I think the command is a tuple, or it could be anything, right? Could be anything in here, but I think it's a tuple. And what you want to do, you want to give it the path to the premake, so bin premake5 -windows.exe, and then yeah, everything is good. Let me just quickly do it like that. And I want to have a new terminal here, and we have installed Python, so the command py should Should do stuff. Yeah, it's doing stuff. That's good. So what we want to do is we run py ./devtool.py, and what you're going to see is when I now run the devtool.py, you're going to see type premake5 help for help, which actually means that we correctly called premake, and premake gave us these arguments. So what we can now do is we can try to call it with help from Python here to see how the tool might help us, what premake is doing. And if we do premake help, you can see a bit of information on what premake is doing. So you can see like premake 5.0 beta 2, a build script generator, copyright Jason Perkins, and the premake project. Lua is used here as well on lua.org from Pokerio. We can see the usage of premake, so premake 5, then we're going to give it some options, action and arguments. Then you can see that we have a few options. We can have a debugger attached, provide files, get help, insecure, interactive, command prompt, OS, generate files for different operating systems. So we could actually now maybe generate Linux files on Windows to basically emulate, yeah, we want to use Linux now. We can provide script path, system script, whatever, overrides default system script, premake5 system.lua, verbose, version, and many things. Now then we also have a few options on compilers. We can select compilers like Clang, GCC, or MinGV, which is useful if we are on Linux. On Windows it's going to be MSVC, but if you are on Linux it's important so that you can actually select which kind of compiler you want to use. Choose a decompiler, yeah, do .NET version, portable.NET, Microsoft.NET, Novel Mono. And then down here we have actions. The actions are actually the actions that shall be generated. For example, gmake2 is used for generating make files. Then we have a lot of presets for Visual Studio, starting from Visual Studio 2005 up to Visual Studio 2022 project files. And we have also Xcode here for generating Xcode 4 project files. For additional help, see premake.github.io. So really what we want to do is we want to now change our call to premake so that it generates something for Visual Studio. And in our case, we use the latest versions of Visual Studio 2022. And now you can see that the usage is premake5. Then we can have optional options, and optional arguments are followed by or after the action. So these two are optional. So really the only thing that we need is a premake5 call and an action, and the action where the generators here that are generating the actual projects. In this case, we want to use Visual Studio 2022. So what we do, instead of the help, we just supply Visual Studio 2022, which is gonna generate Visual Studio solutions. Now, in general, what you want to do, or what you would do on a real project, is actually try to detect which Visual Studio version is installed. This is possible using the Visual Studio installer, which has a command line interface to find Visual Studio, but that's also a bit advanced for today. So yeah, finding the Visual Studio installer and then finding Visual Studio, it's a bit a harder way, but it is possible. Right, so yeah, if I change this like that and we run the dev tool, we actually get a different output. Now you can see that it's no longer saying that we have used it wrong. It's actually telling us that no premake script, premake5.lua, has been found. So in general, how premake works is that the command line is basically just invoking premake. The actual configuration of the project is read from a Lua file called premake5.lua. So the file premake5.lua is going to define in a programming language, the programming language Lua, how our project should look like. So let me actually copy this premake5.lua and let's create a new file here, call this one premake5.lua, and we are in. This is a Lua file, and now if we save that one and run this again, you can see building configurations, running action VS 2022, done. So actually now premake succeeded because this Lua file exists, but premake hasn't done anything here in our repository. Well, because we do not have any configuration here. So how do we get started? Well, the first thing, if you want to learn a new tool like that, is you need to get yourself a bit of information. And how do you get information? Well, you're going to take a look at the documentation, right? I still have it open. We're going to go to the tab doc here, and we have a hell of a lot of section that tells us how we can do premake. So what is premake, using premake, building premake, getting help. We don't care about these ones. We care about writing premake scripts, because we want to write premake scripts to basically set up our project. So what you would in general do is you would start with your first script, which is in general just giving you a bit of a template and explaining what premake is. And giving you a few more options that you're doing. However, as you are on a video here, I'm going to make it a fast way, and I'm going to walk you through that and not following what they have done here. All right, so the first thing that you're going to do in a premake file is you're going to define a workspace. The workspace is kind of like the Visual Studio solution, our CPP tutorial, how we always call this. So what we want to do here as well is we want to do this like that, define a workspace. Now, this seems a bit odd. This is equivalent to that. In Lua, function calls, like that one, that's a function call. We call the function workspace with the string hello world. In Lua, you can also write them like that. A function call like that works as well because it's basically just applying the argument to the workspace function. You can omit the brackets. It's looking a bit odd, but that's how kind of like premake rolls, and I'm just going to use the syntax here as well because this is going to show you a bit of a hierarchy. So it's going to be the CPP tutorial here, or actually it's like the CPP tutorial, but I'm just going to omit this and just call it CPP tutorial. Now, in general, what you're doing is you're writing inline code, right? So the next function call would go in as here, and then maybe if you're calling the third function, it goes there. So normally in programming English, we'll do it like that. However, what we like if we are using premake, we want to kind of like now, after we define the workspace, we actually want to give this an indent because these functions now are going to alter the workspace. Even if workspace was just a function call, it was actually telling the premake build system internally, hey, I want to begin a workspace, and any subsequent function call is now operating on that workspace. So in general, even though workspace is a normal function call, we tend to indent everything that's following after that as well, because it's kind of like logically working on that workspace. And the same is going to go for projects later on as well. So what we do in general is we're going to define a workspace. Now, after we have defined a workspace in premake, we actually need to provide a few specifications for the workspace. For example, here they have provided configurations for the workspace. In this case, configurations, again, is a function, and now we use these brackets with two strings in here separated by a comma, which is just could call this an array. I don't know how the proper term is in Lua, but I think it's actually even array. But the thing is, like, this is again just a function call, and the parameter is an array. So you're providing an array to the configurations function, and that's what we want to actually do here. We want to provide a configurations for that project. Now, configurations is going to tell the build system what configurations the application or the applications can be built in. In this case, it's debug release. It's the same like Visual Studio tends to provide it. Debug and release, debugging configuration, release configuration for debugging and releasing the software to make sure that you can debug builds easily and release you are without all debugging code and have optimized code. That's a general thing that you'd like to apply. If you're writing more complex projects, you might also have something like profile to profile it, which has been strapped out in debug. Like debug, it's solely for debugging, and then you have like a profile configuration where all optimizations are applied, but there's instrumentalization code in here that measures how fast your code runs, and on release all of this profiling code is also removed. Or for example, Unreal Engine has a debug development, a development editor, a development only, and a production build, right? Like debug is for debugging it, debug editor is for debugging it with the editor open as well, development is for developing it with the editor or without the editor, and development editor with the editor, and then production builds or shipping, however that's called. It's used to actually then ship your game, right? These are different configurations. This is just a logical construct for you so that you can have multiple ways. But a general way is debug and release so that you can easily debug but also have performant releases if you actually want to publish your application. Now there is another thing that we actually want to use here as well. I'm going to open this up here in a new tab, and it's called architecture. The architecture is going to give you the architecture on which the application is able to run. So for example, you can see that we have x68 and x68 underscore x64, which is basically 32-bit and 64-bit, which you can also provide with x63 and x64 to provide 32-bit and 64-bit solutions, but there is an intent to deprecate this. This might go in the future. I always like to use it because I actually don't like these ones, so we can just try if they still work, even that this might break. And the general idea is if you have a architecture, you could do this with different configurations. So you could, for example, do configurations with debug 32-bit, debug 64-bit, and release 32-bit, and release 64-bit. And you could supply the architectures dependent on something called a filter, but this is a bit advanced. Now, what we actually want to do is we want to completely decouple this from the configuration. So what we want to do is we want to provide some architectures. But in general, what we just tend to do is we just tend to provide 64-bit. I think, actually, if you want to have, can you provide multiple architectures? I'm not quite sure if it's supporting that. As it seems, it's not supporting this because architecture is just a single. It doesn't take an array. It's one of, yeah, so it's just one. You can just provide one architecture, which is a bit sad, but yeah, in our case it's okay because we're just gonna need x64 because 32-bit is deprecated. We're not gonna use 32-bit, so what we can do just out of simplicity, we can just provide x64 here to just say, hey, our projects are just gonna support 64-bit. And if you don't do this, I don't know what's the default currently. Probably it is already 64-bit, but writing this in here makes it a bit more explicit. So now we have debug and release and just 64-bit. 64-bit. If you want to do like 32-bit builds, you would need to probably do this like they have done that, even through that I'm kind of like don't like how it's done there, but yeah. Now that's the first thing that you do. After that, your configuration and your workspace is correctly configured, and you can now continue on adding projects to that configuration. This is an example for a project, and I'm not going to copy this one by one. We're going to copy this, and not copy this completely. We're going to copy this one by one. We're going to start with the project, and again, I indent this because it's the workspace CVP tutorial, and under this workspace, you're going to have that project, right? So what project are we going to use? Well, we're going to use the latest one, the 09 ini-pp for ini++. And now basically we again telling premake that we now want to actually configure a project, and by providing this like that, we basically tell it this is a project, and every function call that is now following after that function call is going to affect the project. And again, normally you would continue your functions here, but we're going to make another indent here because, well, it's now logically operating on a project, and logically under the project means that we can have an indentation so that it is completely clear where we are currently affecting our code. All right, so now you can see that by default, they are starting with a kind and a language. The kind and the language are basically going to tell you what that project is. Now, the kind in this case is a console application, the example, which is completely right. Currently, we just have explored console applications. So applications that have the console, that open up the developer command prompt, and you could edit stuff in here. Now, this is a normal case. On Linux, it is also just console applications. On Linux, there is no thing differently than console applications. However, on Windows, there are also windowed applications. Windowed applications don't have a console by default. If you want to use one, you would need to write specific code to actually attach a console. And if the application terminates, the console is removed. This is used, for example, on games. If you are playing games on Windows, you double click the game, no console opens up. There's no command prompt that opens up that says game is loading and then the game opens up. No, you double click it, probably a few seconds, nothing is going to happen. At least most of the time, you're going to see like your Steam window or something like that that's telling that's launching the game. And at some point, you might see a splash screen, or the game just directly enters full screen, and you see the game loading in full screen. And this is because it's a windowed app. It doesn't have a console. And on Windows, we have that difference, but we don't need to really care about that. We're just going to put the kind to console app, which is just going to tell premake that this is a console application. If you would want to have a library, you can actually change that to for something like static lib or shared lib, or I think it's called. Actually, if we try to search for kind, you can see that we have like this console app, console application, windowed app, desktop window. This is not applying on Windows. It's also important on macOS. Okay, so on macOS and Windows, it's important. Then you have like also the possibility to have this like as a shared lib, a DLL, or a static lib. We already talked about them. And you have a few more options like a makefile configuration. A makefile in general is just a Windows makefile. It's a bit more advanced. Like on Linux, I think it's a normal makefile. On Windows, it's like this special Windows makefiles. For example, Unreal Engine just uses makefiles on Windows to call their build system from within Visual Studio. And if you would do something similar, you could do this as a makefile. You could have a utility. Yeah, custom build rules, we don't care about this one. You could say something like none, useful for projects containing only web pages, header files, or support documentation. If you have something which is header only, there's no code to be compiled. And if you then add it to the build, some bad things can sometimes happen, especially if you are requiring them. So having this like to none is something that would apply there as well. We have a few more things like Android project, shared items, which doesn't contain build settings, instead using the build settings of any projects that link it. So yeah, there are quite some different negotiations. The most common ones is like console app, windowed app, shared lib, and static lib. We're gonna see all of them later on in action, or maybe in a future video. So that's like the kind, right? The next thing is the language. We can also take a look on how this is documented by taking a look at the language. And the language is basically just telling you what you're gonna do. So as you can see, they are providing several of them. We can actually use C, C++, C#, F#, and D, right? These are like, I think, all .NET languages. I'm not quite sure. I think F# is F# .NET? F#.NET seems like it, right? Yeah, for .NET. And I think D is also a .NET language. D-Lang. Oh, is D-Lang not? Is it not a .NET language? Seems like it. Right. I know I haven't used D at all, but it seems like D is whatever D is, but I don't care. But you have like all these options, right? You can see like we can write C, C++, C#, F#, and D. Most commonly, you're probably going to use C++ and C#, especially if you are doing like game engine stuff and you're using C# for scripting. Then you can have like your script projects in C#, and you can also like configure Mono and the .NET version in here. But that's kind of a completely different thing, right? What we want to do is definitely, for our case, specify C++ because we have a C++ tutorial. And after you have set it up the settings, there's general like the two big cornerstones for your project. After that, you are just specifying how everything works. Now, the first thing that you want to now specify is you want to specify where your binary is going to go. There are multiple binaries that are generated. We talked about the Visual Studio, the build output and the intermediate files. And the build output, the output or target is what's called the target directory. So the target directory is where our binaries are stored. So let's start and configure that one because it's going to be simple. And let's actually start by taking what they have provided here with us. So you can actually see that they are trying to put the binaries into the target files, the binaries into a binary directory. However, we have put them into build binary. So we need to actually change this to build binary, and then they are trying to do this into a subdirectory called cfg build cfg. Now, the build cfg is the build configuration of the configuration. This percentage and then the curly brackets, they are specifying a token. So this is generally, without the content in here, these three characters kind of like indicate that this is a variable. This is something that's going to dynamically change. This is something like the, I think, percentage and brackets in Visual Studio that we also use to kind of like dynamically generate these paths. In this case, I think the CFG build configuration is going to be debug or release. But to actually find out what this is, we can actually go to the documentation and find it out. So if I would search for that, we might get this one, but we don't get it. It's called tokens. Tokens are used inside these into these curly brackets to actually give you some information. So if we scroll down, we can find some examples here. So you can actually see that we have the build configuration in here. It's not really telling you what it is, but it's at least showing you what options you have. You can also see that we have the architecture, and in our case you could see that we had as an output directory the architecture minus the build configuration. So let's do this here as well. Let's add another one, architecture dash build configuration, and just for Visual Studio say we're also going to add a trailing slash because that's how I like it. And I even go further like that because premake is always a bit dependent on where your premake file is. You're going to later on maybe have your premake files separated. Currently, we just have one premake5.lua, but this is going to change in the future. And if you then move the files to different directories, bad things can happen with your path because they are always relative to your build files. So what I always tend to prefix that with where I want to put this. In this case, it's the WKS location, which is the workspace's location. And the workspace location is going to be there where it's defined, or you could also define it manually like that and say, all right, workspace location is in the current directory. And since we are in premake5.lua, which is in the root location, the location of the workspace is going to be our root folder. And then later on, we can use them down in here, of course, with the token syntax. And then this is now in a more explicit path, which basically tells you, right, in the workspace location under the subdirectory build bin, put it under configuration minus build configuration and all the binaries in here, which is exactly how we have done that here. So this is replicating that. Now you can see that the intermediates are not configured. So we also need to configure them. So you can see if we would maybe try to search target here, we might get some options of what we want to use as well. So target directory path, it's there as well. Do we know it's not suggesting that's what we also want to take a look at. However, intermediates are not going to be there. Intermediate, no, it's not in here, right? It is called object directory, and it's actually making more sense. We have put our object files into a directory called obj, so having this actually as a property called object here kind of like makes sense. Yeah, because I also used premake previously to this tutorial. So what we also want to define is an object directory, and I'm just going to copy paste what we had above here, and then I want to put this into the obj directory. And if we take a look at the obj directory, you can see that we then, after the configuration, we also had the project name. So the project name is also available as a token. So if we could go back to token here, you could see that we have a project.name in here. I'm explicitly now using the token because we're going to later on automate these tasks, so that we don't need to copy paste them for every project that we have. So I'm always going to use the tokens. Of course, you could in this case also just replace this with the hard-coded value, but hard-coded values are always bad. Having these always with these nice little tokens is going to make your life easier, especially if you want to later on modularize your code. All right, so now we have specified where our files are going to be generated. So now we know, or now Premake knows what kind of C++ project it shall create, with what language, and then it also knows the target and object directory. One thing actually that I forgot is actually specifying what CPP version. So what you can actually do is something called a CPP dialect, and the CPP dialect is gonna tell which CPP version you want to use. So CPP 20 is what we want to use. So C++ 20 for the CPP dialect value, which we want to add down in here. So CPP 20, so that we are on the latest version and all the code that we have written is going to still work, right? If we are, I don't know what's the default currently on C++, but it might be 17 or something other. Specifying this always makes sense so that you know what's going on. But now you have correctly configured the project. Now there is one big thing that is missing to the project, well, the actual files. By default, Premake is not going to include any files in your project. You need to manually specify what files you want to include. So what you need to do is actually now specifying the files. And there is one thing that I want to do while specifying the files. I actually want to define where my project shall be located. So also the project has a function called location, or it's the same function, but it kind of like detects if you're currently in the workspace or project to determine where you want to go. And now we actually want to provide where our project is. Now our project is at the workspace's location in the subfolder 09ini.pp. And by specifying the location of the project, we actually tell Premake where to put our project files for Visual Studio, so our VCX projects. That were the files that we deleted in these folders, and we need to tell it where to put them back. If we don't tell it where the location of the project is, it's going to put us into the same directory than the solution file, like the workspace, but this is going to give us errors. We always want to have this in the subdirectory. We want to separate all of our projects. Now, as soon as we're going to add files to the project, things are going to change as well. First of all, I want to make this all a bit bigger because we're going to add a lot of files, because I do not really like the default setup. Now, since we have a multi-project setup here, we cannot just blindly include all header and C files like they have done this here by specifying files. We need to actually tell it that it should just add files from the directory of the project, which we can do with tokens again. So tokens Okay, project.location, it's the directory of the project. And from there, we want to include all header files. And we want to include all C++ files. However, that's not, or all C files. However, this is not enough because I already spoiled it. Yeah, we also want to, of course, use C++. So also we want to use HPP. And also we want to use CPP. Additionally, what I'm also going to do is I'm going to include something called HH and something called CC. And also HXX and something called CXX. These are all the common extensions for C++ and C, and I just want to make sure that everything is in here. Additionally, what I like to do is also add Lua files, also add TXT files, and also add our ini files. These are not going to be built because Visual Studio is going to detect that these are not proper source code files, but it makes sense to add this to the project as well so that you can edit them. I'm going to add Lua files because later on we're going to move our build file, our premake5.lua. We're going to move this to the actual projects, not the root premake5, but different Lua scripts for management purpose. And if we have them into files in here, it's good. The same goes for TXT. And I forgot something that I always tend to do. I always also tend to put in markdown files there as well. So all like documentation like files like build files, ini configuration, markdown, and text. It's always good to have them in the project as well so that you can edit them directly from within Visual Studio. And by providing like these file lists, we now have all files in the project, and in theory, we could now start and build our project. But there are a few things missing that are going to be a bit more complicated. As you can see, if we are going back to your first premake script, you can see that we have that section in here. I'm just going to copy paste that one section here, and I'm going to explain this to you in a second after I have formatted them. Now, what these filters are going to do is they're going to operate differently depending on what's inside the filter. So you can see in this case, the first filter is filtering for configurations and the configuration debug. So only for debug, it's going to do what's following. So for debug configurations, it's going to add defines. Defines are preprocessor defines. And in this case, it's defining debug, and which means that the debug macro is available. This is important for Windows. I think on Windows, we also have something called like underscore debug, which is something debug that I'm not debug. There we go. It's something that I might want to add there as well. And what we also do is we are defining symbols on. And by defining symbols on, we basically tell it that we want to have debug informations. Now, a very important info on this filter is that they are also working like a project. So if you're defining project, you are in the context of a project. If you're defining filter, you are in the context of a filter. So if you would add something like location down here, not up here, but somewhere down here, and you write it in there, and you think, all right, now it is fine because it's outside of the filter. No, the filter is only going to be overwritten when the filter function is called again, which is why I like to give the filter function after I am done with the filter an empty array. The empty array defines that the filter is at an end. We could also look this up. I would search for filter here. You can see prefix and keyword. This is how these filters work. And if you would scroll down, you can see several things. You can also like filter for actions, filter for kinds, filter for whatever. I know options. You could have multiple filters. Use filters up here. Filters for files, so embed stuff in here. System not Windows for not Windows. Language C#. And what you can do is to reset filters is called that one down here. So I always like to reset my filters when I'm done with them, even though I directly supply a new filter. If you're supplying a new filter, the old one is overwritten. But I always tend to do it like that so that you can see that this block is in existence. So in this case, it's defining debug and underscore debug, and it enables debugging symbols. Now on release, we are doing something similar. The only thing is that we are not defining debug, we are defining ndebug, which stands for not debug, and it's the common thing that should be defined if you are not on debug configuration. And additionally, we provide optimize to on, and optimize to on means that we are providing optimal code, so optimizations for releases. And this is like your default debug and release that you always want to have in here. Now you could of course also go in and have something like tutorial debug to have like your custom debug macros, or you could also provide some custom settings for, I know, if you're using some external libraries to set up these libraries, you can all provide them in here. And yeah, that's actually everything that you need. I mean, it's a bit longer and a bit more complicated than the default example, but that's the right way to use Premake. And this is how my minimal premake configuration looks for one project. Now, after spending ages writing this code, it's now finally time to run premake again. So calling py-dev-till.py, and you can now see that the output is already different. Building, configurations, running action VS 2022, generated cpp tutorial.sln, generated 09 ini-pp.vcx project. And if you're observing our directory, you can see that actually premake has generated ourselves a solution file, and premake also generated ourselves a VCX project file, so a solution in the project. These were the files that we deleted. So now we actually get the solution, and now it's time to open the solution up. So if I now go inside of my CPP tutorial, you can find that there is the SLN file, and if I double click that, Microsoft Visual Studio shall open up and ideally provide us with a right configuration. So now you can see, all right, CPP tutorial is the solution, one project. If we expand it and show all files, we can see that the config.ini is in here because I added ini files. The ini-pp.cpp and the ini-pp.hpp is in here. The main.cpp is in here as well. It all looks good. If I right click my project and go to properties, you can see that we have different options. This is actually correct. Now you can see that we no longer have 32 bits and we still have debug and release. If I, for example, go to debug, you can see that this string that we had inside of premake has actually been refactored. It says go one directory up. Since we are currently the project directory, we are going to our solution directory, and we're going to go to the build directory, to the bin directory, x68_64 minus debug. So it's not x64, but it is kind of like similar. And the same goes for the obj files. You can see that the correct C++ version has been automatically selected. Application.exe has correctly been selected. If I go to C++ preprocessor, you can see that our debug stuff has been defined, and yeah, everything looks good, right? Everything is as it should be. Everything is configured automatically. We haven't touched anything in Visual Studio. It has been all automatically generated. And now the only thing left to do is actually check if it works. So let's right click and build it and see what it's going to do. It's going to compile ini-pp.cpp, main.cpp, and it should say generating code and done. And now I should be able to run it and everything should be good. And yeah, port John Doe. What the hell is now your question? Yeah, I'm just a bit confused. I have written the owner name to the port. Yeah, everything is working correctly because the default working directory is the project directory in premake as well. So okay, a bit of a mistake here from myself. Everything is good. It's just that I have changed this somehow here in the code. But you can see actually, yeah, the project generation works fine. And now the only thing left to do is to go and copy paste this for all other projects, right? No. That's not how we want to do this. We do not want to copy paste our project setup for every single project that we want to do, right? This is not copy paste. This is not the purpose of a build system. Can see it's like all modular, right? The only thing that you would really need to change if you're now adding a new project in here, the only thing that you need to change is that one and that one. So the name and the location, which in this case is the same thing. So really what you would do if you're creating a new project, you would definitely not want to copy paste all this code. And that's the whole purpose of having this as in the build system and the purpose of premake to be in Lua. Because these are all Lua function calls, right? Project is a function call, kind is a function call, dialect is a function call. These are all function calls with values. And because they are function calls, it means that we can actually make a own function that calls all these functions for us based on a variable. For example, what you could do in Lua is you could provide something like project name equals that one. This is a normal Lua variable. And if I would now use this variable as parameters, now if I use this as parameters, I do need the brackets. But if I would do this here in Lua, and instead of providing the hard-coded values, I could provide them in a function call here and with actual meaningful values. This, by the way, is Lua string concatenation. That string plus that string appended. And what I could do is I could actually provide this as a variable. And if I run this, you can see it hasn't done anything because, well, The Visual Studio solution has not changed, but if I would change this to something like cats and dogs, if I would press F2 and change this to cats and dogs and run this, you can actually see that the solution has been re-executed and or rerun, and you can also see that a new project has been created. And if I go to Visual Studio, it says that I should reload the solution. And if I reload this, you can actually see that our files are still open, but that's a different symptom. But you can see that now our project is called cats and dogs, and we have all the code of cats and dogs in here. Because, well, it is Lua. It is a programming language like any other programming language, which means that it supports variables and functions. And yeah, that's the whole point. And what we want to do is we want to have this project setup code in its own function and manage this a bit differently. But that's something that we're going to do in the next video. The only thing that I'm going to do is I'm going to check my Git. And the problem that I have currently with my Git is that we have all the solution files in here. We don't want to have the solution files in here and the project files because they are generated by premake. And since they are generated by premake, I do not want to have them being generated automatically. So what I want to do is I want to ignore solution files, which should remove the solution file in a second. I want to ignore the VCX project files, right? It's like VCX projects, VCX project, and VCX project.user. And there's also a VCX project.filters, I think, or filter in just singular. But what I want to do is I just quickly want to ignore all Visual Studio related files because they are no longer required. They're going to be always generated by premake on every system. You just need to call devtool.py and then they're going to be regenerated. And in the next video, we're going to make this work properly. And maybe then a third video for Linux. So thank you for watching. I hope you enjoyed, and make sure to like and subscribe, and have a nice day. Until next time, bye.